Greetings, ladies and gents. Here is our plan for today. You guys are actually combining two lessons, 14 and 15. And what we're going to be looking at is how we compare the size of objects, or the size of units. And talking about how some units, even though their number is lower. So looking at fourth versus fifth, fourth being that number is smaller than fifth, but when you look at a fourth, their pieces are bigger. So we're just going to do a couple of samples, and then I'm going to have you guys do a few on your problem set just so you have some good examples. So if I were to take a piece of scrap paper, or you have your math notebook, and I were to compare 1/6 to 1/9. So we know that these two are equal. 1 is 1, right? So we're at least comparing the same number in our fraction. So 1/6 versus 1/9. So 1/6, I'm going to look by making a fraction strip and make another fraction strip. And they should be the same length. Mine are pretty close. The one I'm going to cut into 6 and the other into 9ths. Go ahead and pause while you do that. All right, so what you should have come up with is you should have had 6 and then you should have had 9ths. As best you can. Remember, you want to make them as close as possible. So if I have 1/6 filled in versus I have 1/9 filled in, which one's larger? Well, you can see that the 9th pieces are really small versus the 6th pieces are much bigger. So that makes 1/6 larger. So the larger your denominator is, the smaller your pieces. So the larger your denominator, the smaller your pieces. The bigger your denominator compared to the other, the larger the pieces. And we know that with 1/2. 1/2 is the whole part of the fraction strip. All right. Let's do this next one. Let's imagine we're comparing 7/10 compared to 7/12. We have the same number again. It's not a 1 this time. It's a 7. It doesn't matter. You can still draw your models to represent 7/10 and 7/12. But you should already be thinking, the 12ths are going to be smaller. So I only have 7 small 12ths. The 10ths will be a little bit bigger. I have 7/10. So which one of these do you think will be larger? Go ahead and pause while you draw your model. Remember, they have to be the same length. And sort out or create 7/10 and 7/12. Go ahead and pause while you do that. Hopefully your first guess was correct, that 12ths, since they're so much smaller, only 7 of them is not going to be nearly as large as if you had 7 of the 10ths. So therefore you would eat the bigger fraction. All right, the last thing I'm going to teach you is looking at the numerator. If the numerator is different and the denominator is the same. So let's say I want to compare 2/6 versus 4/6. Go ahead and write that down. Well, since we're dealing with 6, it's the same thing. So I have 2 out of 6 pieces, or I have 4 out of 6 pieces. You could draw out your boxes again and cut them into 6. So go ahead and pause while you do that. So you should have had 6 for both of them. The line should be in the same spot because you're dealing with both. 2/6, 4/6. This is the easiest thing to compare. 4 is obviously larger than 2. That numerator helps you out. All right, last thing we're going to talk about is we're going to talk about problems that have something in common, such as 2/5 versus 3/15. We know that 5 and 15, they are multiples. So 15 is a multiple of 5. But I'm looking at trying to figure out which one is larger. Is 2 out of 5 pieces larger, or is 3 out of 15 pieces larger? So go ahead and draw your models and see if you can figure out which one is larger. Try to do it in your head first. Try to see if you can go, all right, I know when my denominator is larger, my pieces are smaller. But when my denominator is bigger, my pieces are larger. So pause while you make a diagram to represent both of those. Go ahead and pause. So as a tip, what I did is I cut both of these into fifths first. And then I knew that 5 times 3 gave me 15. So I cut each of the fifths into 3 groups. All right, so I have 2 fifths, or I have 3 15ths. And my friends, if they are the same size, like they should be, then you can obviously see that 2 fifths is larger than 3 15ths, which you should have thought, because 15 is much smaller pieces, and that 3 is not that far from that too. But drawing out the model really helps. All right, if you have all of this, what your job is going to be is to get your problem set and to work on your problem set. I've actually given you an example of each thing you're going to find on here, other than the mixed numbers. But honestly, let's think about this. 1 and 1, they're the same. You can just ignore the ones and go right to the fraction. All right, this is a little word problem. It's a bit of a challenge. Take your time. You'll notice it says draw a model if you choose to. You must. It's not a choose, it's a must in my book. So you must fix your problem set so it looks like this. All right, other than that, I want to see you show me. You've got to reason it out. You have to explain yourself. All right, find a partner and good luck. After that, make sure you show it to somebody, do Zern, and then do homework. All right, have fun.